Right. So as you may know, I don't really enjoy support material and I like to avoid it as much as possible. So I'm going to present in this video a few techniques on how to avoid using support material when you can avoid doing so in many cases with 3D printing. So the first type of avoiding support material is this kind. So for instance, if I were printing this part where it's straight up like this on the bed, uh, and I would like to have this ledge here because it needs to fit a pipe on top or whatever, I can just put a 45-degree angle here, or 45 to 60-degree angle here to the vertical, and then that would get me a print with no support. There's a similar technique that you can also use on holes that are round. For instance, this part prints on this face that's highlighted, and the idea, and I wanted to print it on that face for various reasons, mostly to do with it being the most obvious face, but sometimes it's like almost all of the way there, but like not quite. And that was certainly the case with this part, where I could almost print it on that side with no issues, but there were some issues, which is that I want to have this hole where there's a larger diameter on the bottom or on the top rather than on the top, because I wanted to put the screw head recessed into the part. So in order to do this, I would otherwise be creating a 90-degree overhang angle, which is not acceptable. It won't print correctly. And so instead I used a small chamfer on this edge so that it's a 60-degree overhang, and the printer can do those rather than the 90. And that's one trick that you can use if you have stuff like this. Another, I'd say much dirtier trick is when you have parts like this one, where I want to print it on this face because I would rather avoid having to bridge across here and having to put an overhang on these nut traps, and I think there's other reasons why I chose not to do that. And so instead I have to print it on this face. Well, I mean, the part's ideal for this. It can bridge right across here, it can bridge across here, and it's all great, but it's not quite, because we have these holes that need to go through the bottom of these bridges, and so interrupted bridges don't really work, and so we have to do something about it. And for the keen-eyed among you, you may see the solution. So here I've made a small cut into the top part that is 0.3 millimeters deep, basically one layer height. And what this does is it means that the printer will bridge across this way perfectly, that will bridge across this way, and that will just make the hole. The very corners of the hole will still be slightly unsupported, but it's far better than it bridging across and then bridging halfway up to the hole and then like falling in right down to the bed because there's nothing supporting that. I can demonstrate how that looks in the slicer. So here we have it in the slicer, and it's upside down. So if we put it on the right face, then we will see the result. So the result will look like bridge. So you can see there's bridges that go straight across, and then it will turn 90 degrees and it'll make the hole. And this gets support there. And that's one technique. Another technique that you can sometimes use is just straight up like cover the hole over. If you were to, say, make a sketch on this face and then project, extrude, and 0.3, and then just like cover it, basically. I seem to have failed at that, but you get my point, where you make it basically one layer thick, and then you can cut through it just once it's printed. And that's another way of handling interrupted bridges. It's not quite as elegant as the other trick, but sometimes it works better to just cover the bridge rather than do this trick. Depends on the circumstances, of course. So another trick that I use to avoid support material is on round things that are in the vertical orientation. So this here is a part off of the robot that went to nationals, and it prints mostly without support, but we have these circles, and if you remember some lessons from math class about geometry, you'll know that the angle up here will increase. So 45, 60, and then it increases up to 90, and it gets infinitely close to 90 degrees at the very top of the circle because there's a tangent across it. So this isn't the greatest overhang angle, and this is a problem with circles. So often we can increase the quality of the top of a circle if we use the layer editing system in Prusa Slicer, which is accessible up here. So you click on the object and then you click on layer editing. And then from the right, it gives you instructions on how to use it. So we can see about there. If I add a bunch of detail there, then we can get a much finer circle and it will give you better results. So we can see that the layers here get obviously a lot finer, and this improves the quality of the top of the circle at the expense of a very minimal amount of print time. And that's obviously highly recommended if you have circles that are like this big. This is, I believe, a 48 millimeter circle. I've printed 60 millimeter circles, and they turn out all right, but there's nothing to phone home about. Like right here, you can see that on this circle there's a little bit of not the greatest quality at the very top, and that was with a constant layer height of 0.3 millimeters on a 0.4 millimeter nozzle on the Mark III. So pretty much ideal case, and you still get this ugliness. And again, you can reduce it by reducing the layer height in that local region at the expense of a very minimal amount of print time. So I highly recommend that kind of strategy. Anyway, I hope this was informative as to how you can avoid support material in cases of vertical pieces that you would like to have print with no support. For instance, on this part, in the case of counterbores or other changes in diameter of circles, and in the cases of interrupted bridges such as on this part. Thank you.